Our next speaker is Martin Vietze. He's Principal Operation Excellence for Mining Geoscience, bringing over 14 years of experience in exploration and mining geology. He holds an MSc in geology and an MBA from Stellenbosch University. Martin has led major initiatives across Anglo American, spanning geoscience, ore control, global drilling strategy, and technology implementation. His career includes roles such as Principal Global Drilling and Technology, Principal Technology, and Principal Techno-Economics, with experience across diverse commodities and international projects. He's going to talk today about Signal in the Noise, a technology selection story. Martin?
Thanks for the introduction. Thanks for the invite, Dave. And yeah, I'm really excited to be here. It feels like we should be discussing or voting on something really important here. So yeah, all those in favor of the sale of Greenland, no, won't do that. Yeah, thanks. So I'd like to take you through the journey that Anglo American took to identify technology that potentially can accelerate discovery. And I have to start with a disclaimer, unfortunately. So I will be discussing a company that we partnered with and a product that we co-developed. And this is in no way a pitch or a promotion of that product. It's just an example of how the drilling, the technology strategy was applied, and an example of the technology that was designed. So when we talk about noise, this is the kind of noise I'm talking about. So my LinkedIn inbox looks like this. My Outlook inbox looks like this. It's a bunch of technology just absolutely thrown at us. You're wading through all of these things, and everyone's claiming some breakthrough new technology, some groundbreaking new tool, AI. It's just overwhelming. But it could be that somewhere in this noise, there is a signal. There's some real breakthrough technology, but we don't have the time. We don't have the resources to actually wade through of all of this and actually identify the technology that's going to provide you with that breakthrough. So in one of my previous roles, I was primarily responsible for identifying new technology, and I had the opportunity to speak to many of the people behind these messages to try and see if there's anything worth pursuing. And for me, there's about 3 different categories here. One is obviously, yes, it's a breakthrough, or it's something that we should probably pursue. The other 2 buckets, one is snake oil, absolute snake oil, just technology or tools or solutions, it's just not based on anything scientific, but people are selling that as the next big thing. And the other one is, it's existing technology, it's just got a rebrand on it, someone's just given it a new coat of paint. So the question is, how do you go through this? How do you find that signal in the noise? Well, it starts with a good question. So I'm so glad that Ua mentioned that people are asking for LLMs, AI, just saying, yeah, give it to me. Well, what is the question you're trying to answer? And we all think we ask good questions. And to be honest, in my experience, we don't ask good questions. Either we don't ask good questions or we don't have a question. Just give us the data and we'll figure it out. And that's not the way you should be doing it. We have to understand what we're solving for and what the question is you're trying to answer. With the tool, with the solution, with AI, whatever it is, it's something that's really critical. And it's something we're failing out on a daily basis. And you can see by the amount of self-help and business books that are out on decision-making and formulating good questions. Clearly, as humanity, we're not good at asking questions. And a story I like to tell about this, I find it quite fascinating, but it's, imagine yourself, it's 1847, you're in Vienna, Austria, there's a hospital, there are 2 maternity wards. The one is staffed by midwives, and the other one is staffed by doctors. And childbirth fever at that time was a huge issue. Mothers were contracting childbirth fever, and shortly after giving birth to their kids, they would pass away. And the interesting thing was, in the doctor's ward, they had a 5 times higher mortality rate than the midwives. So obviously started asking questions. One of the first incorrect questions they asked was, is the position of the mother during labor resulting in the higher fatality rate? So they investigated that. The women in the midwives ward were on their sides, and on their backs in the doctor's wards. They tested that, nothing came of it. Then they went a slightly stranger question, but it was 1847. They said perhaps the presence of the priest was shocking the woman into getting childbirth fever. So obviously due to the amount of deaths in the doctor's ward, the priest was making quite a few rounds. And they said, well, yeah, it's the shock and giving them childbirth fever, so it's his fault. That obviously came to nothing. And then the doctor, and I wish he had an easier name, but it's Dr. Ignas Semmelweis. He asked the question, so what are the activities that we as doctors do that's different to those of the midwives? And they quickly realized, oh, the one thing that all the doctors do is they go off and do autopsies on all the women that had passed away and then go back into the maternity ward and deliver babies. So it was easy as doing a test of just washing hands, and that resulted in the mortality rate dropping down to what the midwives had. So he asked a good question and got the result. And also he's now known, obviously not very widely, but as the father of hand washing. And I'm guessing COVID-19 is probably the little brother of hand washing now. So now that you understand that you have to ask a good question, you're probably saying, well, what was Anglo American or the Discovery team's question that they developed? So let's talk about deposits. So what do we know about deposits? So, it's an easy discussion. So in the past, we were falling over these deposits out in the Andes, or you could see them with satellite imagery. Now they're covered. We've got some post-mineral cover over them. Okay, that's a problem. They're also getting deeper. That's another problem. So how do we're facing the same issue as the oil and gas industry did when going from land-based to offshore. Just we've got post-mineral cover. They had water. So we're going through those challenges. So we sat and we thought, okay, well, what's the workflow? You could have, geophysics, you could have satellite imagery, hyperspectral from space. You've got all of these technologies. But what is the one thing in the geoscience workflow that always has to happen? What is the one thing you always have to do? And that was drilling. You always have to drill. Doesn't matter what you do. You can have all the anomalies. You could have all the data. You have to put a hole in the ground. So we said, well, if that's the limiting factor and it's expensive, it's slow, and it's dangerous, well, then the question is easy. How do we drill faster, cheaper, and safer? So we had our question. So, okay, we've got our question. How do we answer this? How do we get a solution? So an interesting thing we did is we had an open forum to open up this question, this problem that we had as an industry, to a wider industry. We're obviously blinded with the knowledge that we have. We're sticking with the technology we have. And even though there's been some incremental improvements with drilling technology over the years, it's still kind of stuck where it started, still a turning bit at the bottom of a hole. So the concept of our open forum is saying, well, we invite a whole spectrum of people from a diverse background, diverse industries, and get their inputs on this problem. So it was a 3-day workshop where we invited, and some of the attendees, we had a medical doctor, we had a forensic investigator, we had people that had worked on the Mars rover team, we had people from oil and gas, renewables, you name it. There were people from IBM and Microsoft. So a whole spectrum of people, and really interesting discussions and some really odd ideas, and then some really interesting ideas that we could follow up on. So then we had this whole bucket full of ideas. So we had to characterize them into four different groups to try and make sense of them. So the first one is the improved bottom hole assemblies. So downhole tooling. So think of things like things that are downhole, that are hammering, that are vibrating, that are motors downhole. So that would be in that kind of category. The next one was high energy, projectiles. So think of shooting things down the drill string instead of having a bit turning at the bottom, something that's actually rocketing down there and breaking the rock. The next one was high energy drilling. So think about lasers and think about microwaves, things that different, again, not turning the bit. And then the rather boring bucket at the end, which was the incremental improvement of technologies that already exist. So think of you're just automating certain processes in the current drilling environment. And next, you have to then say, okay, well, I've put them into those categories. Which of these am I actually going to pursue? What am I going to spend time and money on? So we came up with a ranking system to say, okay, well, which of these are really big, good bang for the buck? So the first aspect that we rated on was cost. Obviously, you don't want something that's going to give you an improvement, but it comes at a massive cost. The second one was technology readiness level, TRL. So was this something that was the doctor came up on the back of an envelope, or was this something that was commercially available already? The potential improvement. So was it something that was, even though you spend all of that money, it was going to give you a small improvement or a massive jump, the step change we need? The lead time to that delivery of that improvement. So again, how long was this going to take us? And then the probability of success. So you could have all those things. You could even be a product that's off a shelf. But what is the probability when you use that solution that's going to give you that jump in production? So that's what we rated it on, and that gave us some focus. So we ended up with a handful of things that we pursued. And the one that I'd like to share today is the relationship and the partnership we had with a company called Heisman Engineering to develop the HMR 80 series drill rig. So firstly, a little bit about Heisman Engineering. They're a Dutch family-owned business, and they deliver services, heavy equipment manufacturing services for oil and gas, for renewables, port logistics, and even entertainment. So what they develop is big winches. Everything they do is absolutely massive. So it's big winches, big offshore drill rigs, big cranes, big land-based drill rigs, and then things like Ferris wheels and roller coasters, which was pretty interesting. And another great thing about them was that everything they do is bespoke. Everything is once off. Client comes in, this is what I want, they design it, they build it, and it's fully commercial when it rolls off that production line. It's not a prototype, it's not a beta version, it's not still in testing. It rolls off and you can use it, and that was quite appealing. If you think back about the ranking system, probability of success would be high because it's been proven. So the relationship that we had with Heisman was one where they wanted to go into the minerals exploration space and to the mining space, but have absolutely zero knowledge on what does that mean? How big do the drill rigs have to be? What are the safety requirements? So they had no knowledge of that and needed a partner to help them with that. And on the other side, we were saying, well, if we can design a drill rig that's coming from the oil and gas industry, that's going to be powerful with all the automation, with all the sensors, if that can come into the mining space, that's going to potentially give us a step change. So it was kind of in kind, we're sharing our knowledge, you're potentially bringing a drill rig to the industry that's going to be revolutionary. So what did we end up with? So we ended up with a design. So there's not one built yet. It is on design. If you want to order one, you can order one, and it'll roll off the production line in 12 to 18 months, depending on the long lead time items. But what we delivered was a drill rig it's fully hands-off. Everything, almost like an oil and gas, is push of a button. It's full electric, so it's low noise and low emissions. You can put it next to a small town or village, and it's not going to bother a lot of people. It's a universal drilling solution, so it does mud rotary, it does RC, it does large diameter diamond coring down to around HQ. It does auto rod tripping, so again, push of the button, it'll trip all the rods out of the pipe, out of the hole at a speed of 550 meters an hour. Full rig relocation, so pulling the last rod out, packing everything up, driving it to the next location, starting it up again in 6 hours, and that's with only 2 people manning that drill rig. And you can also fit it with blowout protection. So it's really an amazing rig. There's one currently in a bigger brother of it. So this is the 80 series. There's a 150 series. It's drilling in Romania. And the Hazeman guys have said, there's an open invite to anyone that wants to go and see it drilling. It is there. But yeah, it's really a great piece of equipment. There is, like I say, there isn't one out there at the moment. It is quite expensive. These are oil and gas guys. The costs are slightly higher, but I do think it could potentially give us that step change in drilling. So just some learnings from that. So getting back to the start of the presentation where I said, I think the 4 key takeaways is, you have to start with that question in mind. And I know I'll sound like a broken record, and I had a conversation last night over dinner as well with some people saying, I don't see that happening very often, is starting with a good question in mind. And that's related to technology, whatever, but including data. I see a lot of people saying, just give me the data and we'll figure it out. The data will tell me something. No, you have to start with a question. And then when you're looking for solutions, cast your net wide. Things like open forums are a good way to get some viewpoints from other people. Rate and rank them to give you that focus, and then select a solution that's you're not going to compromise on. But don't compromise. Don't have scope creep. Select a solution that's going to give you the answer. So that is the last slide. So I do have a short video that I can potentially just show. This is of the 150 unit that's drilling. Okay. Yeah, and that's it. Thanks for the opportunity. Thank you very much.
You're welcome.
I do have all the tech spec sheets and everything for that, so if anybody's interested, do have more info. Thanks.